Welcome to the Talking Reliability podcast, where the future of maintenance meets the power of sound. Hosted by Chris Hallum from UE Systems, we're diving deep into the world of predictive maintenance, asset reliability, and cutting-edge ultrasound technology. Whether you're on the plant floor or leading reliability strategies, pull up a chair, or better yet, grab your hard hat, because we're bringing you real talk, real stories, and real insights from the experts who keep industries running. Let's crank up the volume on reliability. So hi everyone, welcome to Talking Reliability with me, Chris Hallum, and thanks for joining us today. First things first, I'm going to put a little reminder out there about the Talking Reliability conference over at the engine rooms at Warrington on the 2nd of October. Check out the website, www.talkingreliability.com, and you can sign up and register today, where you'll find lots of guest speakers talking about all different things of reliability and different types of predictive maintenance technologies. And one of those people that'll be at the event is today's guest as well, and that's James Sylvester from JPS Reliability. So good morning, James, because it is the morning here when we're recording this. How are you?
Chris. Good morning, Chris. I'm all good, thank you. Thanks for having me on.
Excellent. So today, guys, we're going to be talking a little bit about how do we view reliability. It's such a big subject area and there's so many things to cover on this. And we're going to start this with a broad brush, really, between myself and James. James is a good friend of mine, and we've been working together many times on different subjects and different topic areas with different industries. So first things first, I'd like to hand over to James to give a little bit of introduction of himself and JPS Reliability and what you guys do.
Hello, everyone. So I'm James Sylvester from JPS Reliability. In a nutshell, I'm a fitter, turner, apprentice trained on the hands tool engineer who's worked my way up, lucky enough to work in Australia for 4 or 5 years, and had the opportunity to start JPS Reliability with my good friend James Pearce. And basically, JPS Reliability, what we're about is we use our expertise, which is our decades of practical experience, using advanced technologies and methodologies. And what we try and do is we protect profit. So what we do that through supporting through reliability, maintenance, efficiencies, basically in your industries. Also, because we're from the practical side, we do hands-on mentoring training, both online and off-site, totally independent. So when we pick the strategies to help sites, we're picking it for the site, not for the OEM. And the last thing is we got global support now. We got a couple of books and they're globally supported. We do mentoring and assist worldwide.
Excellent. Thanks, James. That's brilliant. So, I mean, you've seen it all, I would say, realistically. You've been into every industry. You've seen...
Been lucky enough, yeah.
Yeah, you've seen some good things, I bet, and some truly awful things at the same time. So, I mean, if you we're talking about reliability, James. I mean, what do you see, or in your opinion, what is the term reliability, and sort of what have you seen in industry, and what do you think they see from it that compared to what you think about it?
Well, reliability is probably one of the most misused words in context and sentences across industry. It's quite shocking. But when you think back to the beginning, where did reliability start? Military, aviation, 1950s. Reliability then was based on mathematical theorems, the statistical methods and analysis. And what they didn't do then is they didn't take into account the failure mechanisms and real life influences. So a true reliability scientific engineer is a statistician, a mathematician, who studies all the physics of materials and predicts their reliability. But what we had in about the late 80s, practicing reliability engineers and analysts who we didn't fully understand the PhD mathematics and the physics and the science, we turned to what we knew. And what we had was an enormous practical experience of the observed failure modes in systems. So we used a large number of practical reliability methods which have been developed, and they were all based on the failure mode effect criticality analysis. But what we don't understand is the true start of reliability, which is the physical, the science, and the mathematics behind reliability. So there's a misconception in what reliability is nowadays.
So would you say it's kind of been watered down over the years in a way?
Yeah, it's been lost. it's been a shame for developing reliability, because the theory of reliability has done nothing in the past 50 years. Because you had the initial scientific reliability, who understood how atoms moved and materials worked, and they could predict reliability of a system. And then it's got watered down because we didn't understand that, and we had the practical side, and that came in. So unfortunately, it hasn't developed much, and it has, in some instances, when people use the term reliability engineer, given it a bad name because they don't really understand fully what they got to do for the client.
No, absolutely. I couldn't agree more with you, James. And I would say also as well, like, this has been around for a long time, this term.
Yeah.
And I think one of the ways in which, I don't know, maybe it's been led by OEMs more than anything else, is that we had the introduction of things like the P to F curve, the IP to F curve, the DIP to F curve. And that put more of a focus on the use of predictive technologies. Where, I would say, predictive technologies are part of the reliability journey, but it's not the be all and end all. And in my opinion, when I've seen different industries looking at this sort of approach or saying that they're running a reliability program, what they're actually doing is a form of condition-based maintenance more than anything else. And they're missing out a lot of other things in there. I've been to places that are deploying full predictive technologies, but they've never even done FAMICA, so they don't even know what assets are actually the showstoppers or the critical ones. And that's where I think a lot of people confuse reliability with availability as well. Because, that DIP to F, and it's always labeled as a reliability curve. But no one seems to really understand that reliability is built into the asset. And by doing a predictive maintenance approach, deploying technologies, yes, that's great. And you might be able to catch something early and prevent something from, a line going down or something like that, improving your availability. But unless they do things like root cause analysis and things like that and feed that back to designers, then the inherent reliability hasn't improved. I mean, what do you think about the DIP to F?
Totally agree, Chris. The thing that I've learned from Dr. K from Limerick University is with the PTF curve, the bathtub curves and all that, that's all mathematical statistical theory. When you look at a plant, okay, the real life PF curve is a line which starts anywhere and goes anywhere, and it changes. Because to estimate asset life is highly complex, and it is a statistical quantity. But when you're in an industrial plant, because when you think about the degradation and failure is a function of so many variables, which in practice you cannot monitor every single variable and predict every variable. You've got things like the time to beginning of deterioration can be affected by if they put Hylamar on the gasket, or they didn't put a bit of grease, or they didn't do this, or the operator whacked it, or they didn't align it. Then you've got a massive variability of a reversible process occurring, like in the materials, quality of steel, manufacturing process. And the biggest effect is like a combination of various parameters like operating, environmental, maintenance, regime, how they look after the machine. The whole reliability thing is so huge and so many things available. These bath curves, which sometimes OEMs say use this, use that, it is in theory, in the lab, it's good.
No,
and what I see is, so to today's reliability engineer, when they talk about reliability and this, people say, they all say they're reliability engineers. It's a reliability engineering job to predict the process, make input into the system design, and return it to a functional state or prevent it fading in the most effective way with minimum consumption of spares, parts, resources. That's what a reliability engineer and sort of high level thing is. And as you say, people don't take into account the very basic stuff. And they just get this little chart. They run a FAMICA from a spreadsheet, from a computer software, which doesn't understand your plant or your machinery, and can pump you out a load of stuff to do. And you can spend a lot of money. I've seen a lot of big companies spend lots of dollars on these FAMICAs from these experts, which don't improve reliability at all, because they're missing the basics.
Yeah, so there's those sort of companies that are providing those sort of services as such, but they've never once been onto the plant with them to help them or look at what's going on, look at their processes, look at their history and stuff like that. And yeah, absolutely. And you touched on it there, James, things like the basics. People aren't doing the basics when it comes to reliability. You know, look at their PM optimization, for example, maintenance tasks that are in there that necessarily don't provide any value. That I mean, looking back in my time, you know, I remember when I was in the military doing a lot of maintenance work, everything was time-based. No matter what you did, everything was time-based. And you would do things on a weekly basis, a monthly basis, a 3-monthly basis. And, you know, the amount of times where, for example, you would go out to do a 3-monthly something on a radar or something like that. Everything seems fine. Everything's great. You've done your maintenance. You've run the system down. You've done what you needed to do. You've run it back up, and lo and behold, boom, there's a failure. Now, if we would have left that and not done that invasive maintenance, would that failure have happened? I don't know. You can't say for sure, but chances are it probably wouldn't have. So, you know, there's some great things in there where we changed the way maintenance practices are done, but it's going back to the basics as well. Mindset, culture, cleanliness, husbandry, things like that. You know, when it comes to greasing, for example, you know, greasing systems. If you don't have your grease systems, you know, correctly organized and clean and demarked and things like that, you're on to failure already and things like that, isn't it, as well? So, James, I mean, there's so many places you can go with this, and I mean, if we think about this as, you know, there's a lot of industry out there that are fully reactive, for example, firefighting. How many times have you've probably seen it as well. You go into a site and they're constantly reacting, firefighting to things around site. And some maintenance engineers like that. They like to be the hero that comes in, you know, sitting in the tea room, having a coffee, waiting for someone to call them and say, hey, this has failed. Go back out there, you know, and be the hero. And you need to look at changing mindset, I think, as well. On that front, with the culture of getting ahead of those sort of things. But if you
worry with that, I'll say the worry with when you talk about changing the culture and from the engineers from the breakdown maintenance is that they're worried they're going to lose their jobs. Yeah, but that's where, as you say, you got to change culture because it's just working smarter, making their lives easier and less stressful. And you will always need maintenance people because things will always fail unless you engineer them out. But to engineer them out might cost a stupid amount of money. So for the business, it will fail at a certain time. So people won't be losing their jobs as such. They'll just be transitioning to a more technology-based preventative way.
Yeah, absolutely. Yeah, absolutely. You do see that. And it's I think it's fear of the unknown sometimes as well, because some people don't, you know, if they don't understand it and don't know it, they fear it. And it's less likely to want to implement it. But something else I would say as well that we would have seen many years ago, but not so much now, is that reliability and maintenance are two separate things. And in this day and age, with trying to reduce headcount and things like that, they've kind of merged the two together. So you have your reliability team doing your maintenance work at the same time. So, I mean, what's your thoughts on that sort of area?
Well, people sometimes see it as a bad thing, merging them together, but it's not, because maintenance, reliability, and condition monitoring, fitting, your Sparky or instrument technician are all interlinked. They're all part of maintenance. They all need to sort of work together. So it's great, and it's better when you do get the condition monitoring people talking to reliability, talking to the people on the tools. So they all should understand each other's role. In the ideal world, the whole team would understand what each other's role is high level, so they can appreciate how it all affects the machine or the system working and producing what it's got to produce. Yeah,
that's almost like, say, that's almost a culture within the group then, isn't it? You're trying to bring everybody in, communicating, talking and sharing those sort of things. And that, so yeah, absolutely. But if James, hypothetically, I'll give you a scenario. So you've got a customer that's, you know, really back in the, you know, traditional way of doing things, the firefighting. They want to move into, you know, a reliability-based program on their site.
Yeah.
What would be the sort of key advice you would give them? Where to start? Where would they start? Where would you start somebody on that sort of journey? Or what would you do if you went into a site to do those sort of things?
Obviously, the answer could change for so many different industries and different factors. But the first thing you got to say to me is, do you actually understand your situation now? Have you got any data, any figures on what's failing and how often it's failing? Because there's no point fixing things if they don't realize things are broken and they're not tracking it. Because everything we do, we have to justify the job. Even when I worked in mining, we were part of the same business, we had to justify our existence. How are we helping production? Because it's all, end of the day, it's pounds and pence, dollars and shillings, and it's how much the company can make profit, because that's why it's in the business, to make profit. So the very first thing would be to document where they're at. What are they doing? What are they failing? If they haven't got any historical failures or any good data, then it's going to be hard to prove or justify going forward how much you're saving the business. But the very basic thing in most industries, honestly, it could come down to the good old stethoscope, literally. So a screwdriver to your ear. It's listening to bearings, because some plants are that bad that you can walk around and go, knackered, knackered, knackered. Oh, by the way, if you change that simple bearing before it fails, you're not going to have to replace your pulley, your roller. So the very basics. And when you, so that's the first sort of level, is a very basic common sense, walk in a line, trying to teach people how to recognize things failing. And then it's the lifeblood of the machine, oil, grease. If you can then fix that, start fixing that. But don't forget, this is where we can talk about this for hours and hours. But then your lubrication is affected by your alignment, by your vibration, by your thermal, by your ultrasound. That's all affecting your lubrication, how the machine is, the old machine, the bed plates. So there's no one like silver bullet to fix it. It's definitely, when you assess a site, you start on the very basics, common sense, walk in the line, oils, lubrication, ultrasound, vibration, thermography, and bring them all tools in. There's no point companies spending 50, 100 grand on vibration if they're not doing the basics. There's no point you spending thousands on this new fancy oil when you got seals in your gearbox which leak, because you're still going to change the oil every 6 months because it gets contaminated. So it's just sitting back and assessing, and hopefully people can get a good support which give them straight up answers how they can help the company. It's a hard one to answer, Chris, but I mean,
it is, James. It's almost like a loaded question in a way, because there's no right or wrong answer in some instances either as well, because for each, as you said, each scenario can give you a different outcome. I've seen things before now where people have tried to deploy like an ultrasound grease caddy to help improve their lubrication program. I've been to site to help them to use the technology, and then walked into their grease store and they couldn't identify which grease gun had which grease in it, for example. And the grease gun they picked up was lying on the floor. And I kind of said to them at the start there, guys, look, we need to take a few steps back here. And this needs to be remedied first of all, and get this in good order, because you can use a bit of technology, but if you've got grease there that's got contamination in it, or the wrong type of grease, it's not going to help you anyway. So it's, like I say, some people like to go forward quite quickly before just take a step back and just observe and look at the bigger picture first of all, I think. So, this is a big subject, and you could talk for hours on this, I think. We have, haven't we? The amount of times we've sat there talking about this topic is, we've done lots of talking. No. I think what we could do here for now really is, I think, this is an overview of reliability from our perspective and our opinions, and it's honest opinions from our perspective as well. And we're going to get back together as well, aren't we, James, in another episode, I think, where one of your specialities and one of your favorite subject areas is vibration, isn't it, James?
Yes. We've got we're doing some great work in vibration dynamic absorbers, and hopefully we'll be able to have a chat and I can show you some stuff we've been working on that one.
Yeah, absolutely. And another thing I'd like to plug as well towards the end of this discussion is the Book of Gold, James. Your published books. I mean, would you like to let everyone know a little bit about the Book of Gold?
Yeah. So the Book of Gold is a child of our first book, Enhancing System Reliability, where When I learnt stuff, I always had to write it down. I had to write it down a few times in my own words for me to get it to sink into my head. And I wrote and I kept my books, and then I put those books into a big published book which had some case studies. And that book went everywhere over the world, and people did say the case studies were great. And it's not that I'm organised or I got any special OCD powers, but for the last 20 odd years, if I find anything interesting, I would file it away in a system. And luckily enough for me then, I had 20 years of gigabytes of issues and things I found. So myself and James Pierce, as we started JPS Reliability, we put that into the Book of Gold. So now that book is full of, from the last 23 years, vibration problems. We've got some thermal in there, oils, lubrication, where we describe the problem. We show you the vibration, the squiggly lines, put arrows to point at what it is, and then it's stripped down and we show you what we find. So it's like a Haynes manual as such for failures in different stuff.
No, absolutely. They are fantastic books, James, and I still have your first book with me as well in my office.
Yes.
That you gifted me some time ago, and it's been very valuable. So that's great. But I'd like to thank everyone for listening again today. Don't forget to follow UE Systems and JPS Reliability, that is, on socials and on our websites. What's the website for JPS Reliability, James?
Literally jpsreliability.com.
Excellent. Brilliant. So guys, thanks for listening, and don't forget Talking Reliability Conference in October, where you will get to see myself again in the flesh, and also James Sylvester, and you can quiz him on anything vibration and reliability based. So once again, thanks for listening, guys. Thank you, James, for joining us today.
No worries. Happy.
And
Cheers.
We'll see you all again soon. Take care.
Bye-bye.